Okay, so to give me the opportunity to talk here. And I would like to have some comments based on basic natural science or physical principles, and particularly to the questions of the limits to growth. And I would like to speak about the limits of growth of humanity and how this is actually associated with the fact that we are actually on the Earth, and what are the natural laws which determine our development and our possibilities and the limits of our possibilities. And where is the... Okay, so this was already mentioned. The Club of Rome had a publication in 1972 where the resources, that's the blue line, was estimated to decrease to the half and even furthermore by 2030. We are already very close to that. More or less all resources what we have. The population would increase and then suddenly drop. The amount of food would also decrease and drop. And everything, pollution will increase exponentially. So that was the development. The fact that we are here and only 10 years from this end of the world certainly indicates that that is probably not what is happening. And as we have heard from Norbert Crow, there are actually the development is increasingly going ahead. So this is, of course, a mistake. And so I would not agree that due to any climate change or anything, we are facing this danger here. And if we look to then I am also not agreeing with our speaker who said that we will saturate, because you said that our way of developing is that we develop and then we will stay like that forever. Okay, so then if we look more carefully, for example, the human population, this is from a talk of Tamás Kocsis at ISIS, given just last week, is that, thank you very much. Yeah, that you have such kind of exponentially looking changes, and then, of course, one would believe there is a saturation. This is when humans started agriculture and was more effective, and then it saturates for a while, and then at the Industrial Revolution, there is an other exponential change. So we have saturation periods, but then we can have more change. So that is crystal clear in our history as well. And then what is actually happening? We see that these changes are actually well describable by the change in resources. The resources do not stop. I mean, we have seen that some things like wood or coal might not be infinite, but as a matter of fact, they are not used anymore so much as before, except maybe in China. So you see that there was a development when steam engine and whatever was invented, and then it was abandoned. And there is another development due to oil and natural gas, and then that decreased. And then hydroenergy, and the last one is nuclear energy. The nuclear energy is, as a matter of fact, provides you limitless energy. I mean, it is exactly the same energy what we have from the sun, just it can be realized here on the Earth. And the ITER, or ITER, in Caradache in France, is already under construction. The walls are already standing. And by 2018, it will be about 500 megawatts. So that is exactly like one block at the Paks nuclear power station. And effectivity will be a factor of 10. So it is maybe true for Europe, as Norbert said, that our energy consumption is not increasing anymore, but that doesn't apply to China or Africa, where the energy increase is still going up. So the Earth's energy needs still need lots of more energy. And particularly you see this step structure if you look for the energy need per capita. So the energy is not a resource which is constraint for us, and although a specific type of energy is constrained, but not energy altogether, and one kind of energy can be replaced by another. So that is what we have to keep in mind. Oops, not this way. Yeah. Now, the Club of Rome, if we go back to the fundaments, the Club of Rome had another idea, actually even before, the heat death of the population on the Earth, namely that we have more and more radiation. This will lead to burning more and more material. Then this material everything will be just burning up, and then we will have a heat death. Now, this argument was actually killed early enough that we are here for several thousand or million years, and this did not happen, and why and how is that possible? That means that we get energy from the sun, and the Earth, and that is actually, bright bluish white color light that measures actually the temperature of the radiation. And we are emitting the same amount of energy roughly at a lower temperature at infrared radiation. But this is about the same, so the Earth is more or less stable, so the Earth can survive. But what happens with a quantity which is called entropy? Now, most of you don't know probably what is entropy. If we look for a piece of material and we look for the complexity of the material, if the elements of this material are just completely randomly distributed and they have nothing to do with each other, this is very high entropy. So if you burn something, then you increase the entropy. If these elements are organized in a very complicated structure, that inside your body you have very complicated molecules, organic molecules, and then they are actually organized into complicated biological cells and DNA and whatever, then this structure, like both in humans and in plants, it's a very complicated structure. The information content of this kind of material is very, very high, and that is called negentropy. So if you eliminate the information from a given piece of material, then you have high entropy. If you have very high information content, that is negentropy. You see that on the Earth, if we look for millions or thousands of years, you see that the level of complexity, also in technology as well as in the human life and living life, is actually increasing. The reason for this is that this entropy, as I mentioned what it is, can be calculated like the incoming heat from the sun at 6,000 Kelvin radiation, and the outgoing heat at the radiation temperature of the Earth. And then this is a negative quantity. So this doesn't change, or it will not change, not even 100 or 1,000 or million years from now. So the entropy and the possibility of this radiation is always there. So our development, which lasted very many millions of years, still will be possible. So the Earth can develop. And what else do we need? And then I have to say that this is somehow not enough, because if we look at this rule, then you could look at the Mars or the Venus, and then there is no life on them and so on. So that's not enough. In order to make these complex molecules and complicated structures, you need a rather stable situation, good temperature, roughly like room temperature here, and we need a thermostat, contrary to what you say, opposition to you. We have a thermostat here on the Earth. We have water in 3 phases. There is ice, lots of ice, doesn't matter whether it's on ground or not, there is some rule whether it's ground or not, but the amount of ice. Then the water, liquid water, and then water vapor, 3 phases. You might know that it is easy to heat up water from 60 degrees to 70 degrees, but it's very difficult and you need lots of energy to evaporate it. The same is to make ice out of it, you need to put it for a very, very long time in the refrigerator, while just to cool it down by a degree, that's not a big deal. So this is called latent heat. This latent heat is actually our thermostat. Until we have a gram of ice and the amount of vapor, this stabilizes the temperature of the Earth. So that is why generally the Earth's temperature will not change much. It will change less than 5 degrees, or maybe even 10, but not more. That is stable enough for life to be created. In Mars, there is no 3 phases of water. There might be some water, but it's so cold that complex chemical reactions due to the very low reaction time at very low temperatures cannot take place. Therefore, life did not develop. On the Venus, 1 minute, that might not be enough, but on the Venus, temperature is too high. So what happens with all these materials, they burn, and then the entropy, of course, at a higher temperature, it would be there, but it doesn't help. So that's why this relation is important. Okay. So then one more thing. Then if we look for the resources, we certainly have a limited surface of the Earth, and if we look for the human population, it certainly doesn't have enough space. I mean, if everyone has 5 children, and then he tells the sons that you also have to have 5 children, and so on, then after a few generations, certainly we will be a little bit too dense and we could not walk next to each other. So that would not be very sustainable. So the whole Earth cannot have this kind of a policy that everyone has to have 5 children. On the other hand, if you have only one, China had famine in the 1960s, so they decided that they cannot multiply so extremely, and now they have plenty of food, and they realized that this one-child policy is not sustainable either, because then the old ones cannot be supported and fed. So just yesterday they introduced, I just learned it from Yilong, that yesterday they changed this policy to the required 2 children per person. So the sustainable, what is sustainable, after people are realizing that what is sustainable, they cleverly adjust to the situation. Okay, and then I just dropped the other comments here. And then I would go back to this was already discussed in several talks, this 7th anniversary of the United Nations General Assembly. And particularly the issue of energy was one of the 17 goals. I mean, Norbert mentioned many of those goals, not all the 17. And what is important that this is agreed by all people, that we need affordable, that means sufficiently cheap, reliable, sustainable, and modern energy for everybody, not only in Europe, but even in Africa and China. And then whether it should be renewable or not, that's nice if we have increased portion of the renewable energy in the energy mix, but the energy mix itself should be sustainable. And recent policy indicates, for example, that this forced renewable energy deployment in Germany led to a situation where the environmental pollution increased tremendously, much bigger than before, because they have to balance the missing intermittent renewable energy by brown coal power stations. That is certainly not the way to go, so one has to choose the correct energy form. So, So I would conclude that science is important, natural science is very important, and we have seen, this is more or less mentioned already here, lots of advantages, and many of these advantages are actually the results of earlier developments, but the only way to go ahead and go several steps of development, if you are working further, and further promotion of science and technology is important, and we have to work for that direction. Yeah, thank you very much.
So, ladies and gentlemen, it's a great honor to me to be here, and I'm really grateful for the opportunity because for the invitation, because it was a great opportunity to think about what am I doing as a researcher, and why am I doing that, and how is it connected to sustainability, and what should I do if I would like to do research that could increase the quality of our life. Because it was important for me, because to tell the truth, when I was a PhD student, I was thinking about science as a Nobel lecturer, Richard Feynman, who claimed science is like sex. Sometimes something useful comes out, but that is not the reason why we are doing it. But of course, I realized we have to have a certain goal, and even if we would like to get some money for our research. And as I'm getting older, I'm getting to feel the responsibility. And I was looking for strategies. What can I use to focus my research? So I'm sorry for this subjective presentation. And for this, recently, I found this important document, the Strategy of Sustainable Development, accepted by the United Nations, that defines 17 specific topics that a scientist, and I think everybody should deal with. But to tell the truth, and there are more than 200 targets. But to tell the truth, it was not so personal reading. I was doubtful, what should I personally do? And for this question, I found a really nice answer in a document that was also recently published. This is an encyclica of Pope Francis, who claims that sustainability is so important issue that no branch of sciences and no form of wisdom can be left out. And if you think about, as I mentioned, I'm a data scientist, so I'm always analyzing the data. And I was looking for the number of publications, international publications related to sustainability. And it seems it is growing also exponentially. But it's also interesting to see what kind of branch of sciences are dealing with this topic. Engineering, mostly engineering, it's interesting, and only 20% is related to social sciences. And I'm also analyzed the network of the topics based on the abstracts and the terms of the abstracts. And I especially analyzed the works of Hungarian scientists during the last 3 decades. And I recognized only 45 publications of Hungarian scientists working in social science were related to sustainable development. And it is only, and these topics are not really focused on sustainable development. So I believe there is a need for much more interaction among these attractions and among these works. And so there is a need for a new kind of science. But of course, this is not my invention. I met a nice paper published in 2001 in Science. And in this paper, there is 7 questions were arised to define a new kind of science. Sustainability science. And the main questions are, how can the dynamic interactions between nature and society handled and modeled? And how the long terms should be modeled and handled? Of course, my time is limited, but as you can read, these are really important questions. And I think the traditional science is not applicable to answer to this question. So there is a need or a new kind of science, Science 2.0. And this is also not my invention. This concept has been published in 2008. And this new science is claimed it should not only focus to describe the relationships among the known concepts and terms, but we also have to predict the interactions. And we have to analyze the mixture of people and technology, and to analyze it, we do not have controlled experiments. We have to collect this data from our real life. So there are several attempts related to this direction when several researchers are trying to incorporate the insights of economics, psychology, and sociology into design of experiments, and to get this knowledge to develop a policy that could be used for politicians. But I think we have to be really careful because it is still related to the scientific view of Descartes, that who assumed we can master the nature. And I think this is not always possible. So the further of our consciousness extends, the more our responsibility increases, and the more we have to consider. So that's the reason I personally interested in the science of complexity and how we can increase our knowledge related to this issue. Thank you very much for your attention.